Okay, hi everybody. Welcome to today's class, and today's class is more of a discussion. So we'd be discussing, the agenda basically would be some discussions around the day-to-day life of a data scientist in general, how the job responsibilities go, and how it's structured. And then we're going to discuss about some questions that came up, like one-off questions like, is R more popular or Python more popular? In terms of the job market and how it's conceived, how that is considered by people in the industry and what their opinions are. And then based on whatever time's left out, we're going to move into our next chapter after that, which is again the formal class on the next topic, which is about random forests, which is a very popular machine learning technique. And it's more of a decision tree based technique. So there are techniques like SVM, which fall under what is known as kernel methods. There are techniques like neural networks and deep learning, which fall under the neural network area of techniques, family of techniques. And there's obviously a lot of statistically inclined techniques as well, like the generalized linear models and additive models, linear regression, etc. Of course, all these techniques have good statistical background, regardless of what family you're falling under. Maybe some more, but some are less. And random forest similarly falls in a bucket of techniques known as decision trees, because you're trying to build a tree structure, literally, and the leaf of the tree has the final classification as you parse through the tree. So, all right, that's set aside. Let's get it started officially, and let me give you some thoughts and opinions on the data science job market and the industrial responsibilities in day-to-day life. Yeah.
Pranit, can you share your screen?
Yeah, I mean, there's nothing that I'm sharing. It's just a discussion at this point. So I'm just talking about the day-to-day life of a data scientist in general for a couple of minutes. That was one of the topics.
Oh, sure. I'm sorry.
Yeah. So, okay. So day-to-day, I think a good way to get a good feel, because there's a lot of variation in terms of the data science responsibilities from company to company and domain or industry to industry. But one thing that is more widely accepted now was also put together actually in a news article, a very popular news article on data science. It's known as this categorization of data scientists, which people informally call the type A data scientist versus the type B data scientist. Now that classification literally trickles down into the day-to-day responsibilities based on whether you are joining a type A data science job or a type B data science job or somewhere in the middle. So what are these two things that people are mentioning? So type A data scientist is the kind of data scientist who has a profile that is more inclined towards research and who really has a better understanding of how the techniques work, and he can develop his own techniques. And those are the kinds of areas or like day-to-day, his style of work is more like a problem solver from a data science perspective, and he's more inclined towards the science part of data science. So there are some jobs that really require type A data scientists, and people are looking on the lookout for them. And from a job seeker's perspective, some people are more happy to be in that kind of a job. Okay, now the other category is the type B data scientist, which was mentioned in the same article, which basically says that you're someone who knows data science to some extent, but not as extensively as a type A data scientist as far as the science side of things go. But you're more of a system builder. You're like a engineer or a system builder who's more inclined towards software development or tool development, but are also aware of data science in general. So this kind of person may not be very good at developing his own techniques or own variations of techniques or doing research as required or using other people's research and reading papers, whatever it be. So he's not as good at that, but he's reasonably good at system building and software development and data engineering, while being somewhat aware of data science for sure. So that's the type B data scientist role. And then there's companies that are specifically seeking for that kind of people.
as well at times, just like there are companies that seek more of the type A kind. And similarly, there are job seekers that are more happier in that kind of role, or maybe they're trained enough and more comfortable in that kind of a role than the type A role. So this is something that one needs to decide in their minds. It doesn't mean that once you're a type B data scientist, you cannot be a type A, or the other way around. The process of learning always continues, right? It's a lifelong process, but you start somewhere based on what your strong skill sets, strong points are for now, and then you try to increase your breadth into other parts of data science. So let me give you some examples. Well, I think since this is being recorded on video, as long as it's circulated internally, it's okay, but it's not appropriate if I mention company names, and if the video is going to be publicly stored. We need to be a little careful about that. But for the internal purposes, for example, companies like Microsoft and Amazon, Google, Facebook, Dropbox, the big size companies, the popular companies are very much segmented in a format that they hire a majority of type B style data scientists, which are more of system builders. But they also have these pockets within the company where they really, really need type A data scientists, although it's not as large scale or wide-sprung as the type B data science hiring spree that they'd go into. But there are pockets of the company. And when I say pockets, I don't mean very minute pockets. There's a reasonable chunk as well, but the majority is type B, but the minority is not very small minority either. So a reasonable pool there too. So you're working on more type A data science problems, more researchy kind of roles. Then coming to, we talked about some big size corporations. Let's talk about some specific domains or industries and how my perspectives have been on what they're looking for in terms of type A or type B. And then we can also talk about startups a little bit in the end. So coming to manufacturing kind of areas, there's a lot of statistical analysis that is done in analysis-based hires that is done in manufacturing companies as well. So there I've noticed that they care more about the problem-solving aspect than a system building, right? Everything in the world is not about software, obviously, a lot of people in the world these days are using the softwares and programming based skill sets. That is for sure guaranteed, but everyone in the world doesn't care only about software building, right? Everything's not a software company, right? So when you're coming to manufacturing, they don't care about how good of a software tool you're putting together. They care about, are you coming up with scripts that solve a problem, and is it benefiting the company just through problem solving, not about building a software tool or a package or something. So they're more inclined towards type A. Now, if you look at pharmaceutical sector, they're very inclined towards type A. They care very little about software building kind of data scientists. They literally hire PhDs in statistics and machine learning, mostly statistics, solely to solve problem-solving related stuff, more like type A kind of problems. So that's how the pharma industry is very, very inclined towards type A. Financial sector, there's a good mix of type A and type B, but they end up hiring type A skilled data scientists because they are able to pay and make a big hire. So I'm not saying they literally pay one person a lot of money, but I'm saying they have enough money to hire a lot of people. Industry, they literally hire all across the board, but they're also hiring a lot of type A data scientists and PhDs, but they end up using them as a type B data scientist. That is something that goes on in companies like Amazon and Microsoft. You would see people with wonderful backgrounds on the type A side, but they end up using them as a type B person who's going to get maybe 10 or 15% time to, roughly speaking, like a crude approximation to solve and do some creative problem solving, but maybe most of the time the systems and the scale of the company would keep them busy just at doing software kind of stuff. So that's what happens in the Microsofts and Amazons and Googles, although they have pockets of type A. But financial sector, it's very well known to be that they hire all kinds of people with all kinds of backgrounds, and they end up using them more as a type B kind of person than a problem solver. So coming to Startups, just by definition, since they're taking a more riskier path as a company from a business perspective, they hire sort of the variation in the kind of people they're looking for and the kind of people they end up hiring is a lot. So I cannot say, just like I've been coding about the big companies in the Bay Area or the financial sector and making a more wide statement, I cannot generalize as much for a startup. It's very much on a case-by-case basis. There are startups that hire people solely for problem solving. And the science side of things, there are startups that hire people solely for system building and somewhere in the middle. So there's a variation of everything. So it's really hard to generalize for the startups. It really depends on what startup you're trying to get into or going to be working with. So that's one way of looking at the job market. Now, of the kind of people they're looking for. So there's room for everybody. That's the positive side of this, right? You may be more of a system builder, so you would have room to move into, get acquainted with data science a little bit and continue your learning while you get into the field and in terms of some job title that's more data science. Or you could always be someone who's more inclined from the science side of things and who's beginning to learn new languages and tools, and then so he can expand the other way around towards the type B and find it up. So there's room for people. The market is, there's the supply demand is very much in the favor of the job seekers. There's so many people, and from the company's perspective, there's a negative to it, but that's not a negative from a job seeker's perspective, which is, let me just quickly say that it's kind of getting more and more known clearly that there's a lot of people that people refer to as fake data scientists, because they do end up having a data sciencey title, but their knowledge is nowhere close to being even a reasonably, at least like a reasonable at a reasonable bar that we can at least call him like, okay, he knows some amount of data science. A lot of people the data science title. That's the fake data science market. So companies are very concerned about that. And then there are people in
Pranita, we couldn't hear you, sorry.
The last part or not at all?
Like it all went off very low voice. It's not audible.
Okay, so can you give me a heads up on till where you were able to hear, so that I can get back?
Yes, a couple of seconds. That's it.
Okay, sure. So yeah, I was talking about the pros and cons of this type B data science situation here. So the job seekers have more positives on their side because there's some room for everybody, right? Whether you're a system builder moving into type A roles or type A person who's learning more into the system building roles. So there's room for everybody. From just to code, there's an issue from a company's perspective. There's a lot of negatives, right? The one from the employer's perspective, which is it's getting very well known these days that there's a lot of people that people are literally referring to as fake data scientists, and I would agree upon that as being a true reference because these days I've seen a few people once in a while, which a lot of people are trying to talk about these days as well, that they might end up in a data science role, but they may not be knowing anything about data science. So that's an unfortunate part of the current job situation, the market situation in the data science area. But it doesn't affect the job seekers at all, right? It's an issue with the employer's perspective because the supply and demand the demand is so high, the supply is kind of short these days, that there's a lot of people who have no idea about data science but end up with the data science title. There are two ways a mistake like that could be made. One is the hiring manager or the group that is hiring for this role doesn't know what data science is themselves, right? They may be some MBA person or some other engineer or some other candidate or like a software developer or a software engineering manager, whatever it be, right? That does not know what data science is. So they end up hiring people they think would be able to do good data science, but they do not know that, right? So those are the people we refer to as a fake data scientist. There's a lot of those kind of people around as well. Now, the whole reason the supply and demand is so skewed is bringing, the fact that this whole supply demand is very skewed is the reason that there's a lot of courses coming up, boot camps like us, we're trying to bridge this gap where the demand is really high and it's projected to be very high for the next 20 to 30 years for sure. There's a lot of universities that are literally starting data science programs. More classical programs like statistics are sometimes changing their title of their department as statistics and data science. That's been done even in like very popular big schools like Yale. Yale has converted its statistics department name as Department of Statistics and Data Science. There's a lot of people in the stat and computer science departments that have started MS in analytics or MS in data science programs. So all this is a good sign from the job seeker's perspective because the demand is high. Now, coming a little more focused into the day-to-day job responsibilities. Again, if you're ending up in a type A role, your day-to-day job responsibilities are very different and dictated differently than a type B role. So just to recap, type A is referring to the more researchy problem solver who has a good idea about how things work. Type B is more of a system builder. He doesn't have a very good idea of how things work, but he's good at putting things together that they work as a pipeline in some form or the other. So they may not be able to solve problems across the board, but they may be able to solve some problems and put together systems that work well end-to-end in the board. So it really depends on what kind of role you're looking for. So if you're looking for a role in more software savvy or like an internet company, then being a type B data scientist is more than enough to end up a reasonable role. So your day-to-day responsibilities will be again similar. You would be ending up, your day-to-day firefighting would be about maintaining systems and making sure you're deploying things continuously. You have some Scrum process, which you guys might be aware of, right, in the software world. You would be worrying about how well you're testing your code before you deploy it into your production systems. Production quality is important. You'd be firefighting with collecting data from databases. You would write your own queries if it was a SQL database, or you'd end up learning to, get your way around NoSQL technologies like Spark or Cassandra or Redshift, whatever that particular group of yours would be using to handle big data. So these are the things that would take most of your time, and you would spend a smaller percentage of time developing and deploying models. And when you develop models, you would use existing frameworks, existing libraries, because by the definition of a type B data scientist, you're more of a system builder. You understand how these models need to be evaluated. You understand everything, the metrics, but you don't develop algorithms and models that are very much tailored to solve the problem. You use what is popularly available. So you might use deep learning packages, so more popular stuff and libraries and packages, and put things together, right from data reading from the querying part till connecting the pipelines between different tools and interfaces, between your data and the scripts that are going to solve your model or deploy your model, and then productionizing it. So this is the type B kind of role on a day-to-day basis. So it's basically a bit of development and a bit of data engineering, a little more of a bit of data sciencey background of understanding of how models are trained and deployed. If you're in a type A role, then your job responsibilities are again similar to the definition of a type A role, which is people will tell you about their current different 5 or 6 business problems that they're looking at currently, which was the reason they would have hired you or the other people along with you that they hired in the data science role. And then you would be responsible to develop ways and algorithms and techniques yourself, apart from just using existing ones, in a very tailored way that it would solve that particular business problem of theirs. So that's the type A role. There you're putting more of your thinking hat into problem solving than system building. Once the problem solving is done, you would spend a lot of time into validating that your idea would work or testing for it. If it doesn't work, you go back to your drawing board again. You again think of how to solve the problem that the business is asking for from a quantitative perspective, right? Because you're a data scientist. So it's not qualitative anymore. So everything's quantitative. And you're going to figure out how you solve that problem. Again, you would, from the drawing board, you would go back to testing your ideas and validating it. And then you would probably generate some dashboard or whatever your way of presenting the results, or come up with a presentation, maybe a PowerPoint presentation, or maybe do a generate a report to validate the fact that your algorithm and your idea that you come up with is solving the business problem. You show the metrics that it is solving it in terms of validation perspective. So this is some sort of a prototyping that you're doing. You don't care about, is it a production scale system where everything is connected from data reading to, the solution. People don't care about it because they're hiring you solely to be able to figure out how to solve the problem because the problem is big enough. Once that has been validated, you would be supported with a lot of software engineers at that standpoint if it's a software-based company hiring a type A role. But so they would end up make sure that your idea gets converted into practice, and they would give you all the resources to work with you. Give you as in they would connect you the resources to work with you to deploy your idea into the production scale system. So you're not worried about system building, you're worried about proper problem solving day to day. For a majority of your time, you're only discussing with other people and supporting them productionize your idea once you validated it. So that's the type A kind of role. Any questions at this standpoint on the job day-to-day responsibilities or job market? Yeah.
This is Kamal here.
Yeah.
So can we say type B is data analyst?
Data analyst usually would be is a mix. This is a mix. So he's not good at type A or type B. He's a mix. He knows a bit of type A where he can analyze some data, but he may not be able to solve very big problems by himself. But then he's not a very good software engineer either, right? Not a good software developer. That's the reason you're not calling him a developer of any sort. So he obviously can, he or she can obviously can code and use the software these days. So I would say they are a mix of type A and type B. Not good at either though. That's the thing. Like a type A data scientist is good at type A. Type B data scientist is good at type B. These data science analyst is not good at either, but their strong point is that they're a mix of both to some extent. That's their power. Yeah, basically.
All right.
Yeah,
Thank
cool. you. Anytime. So any other questions? Feel free to ask any questions you have about that. It could be day-to-day or anything about data science from a practical perspective, right? Job market, anything. Yeah, okay, yeah. So let's shift gear to that. So R versus Python. So from a software developer, like a software company perspective, I will say Python would be more preferred if your manager was a software engineering manager himself, right? Because all they would, in general, this is so nothing stays like 100%. This is a generalization of the world, right? This is in majority this would happen. The reason is because they would consider that Python is something that a lot of other developers are more aware of than R, which is true. And they would also consider that maybe Python is a little more scalable and maybe easier to integrate into a production system. So from that perspective, they would be inclined towards Python. But then they would always say, hey, but if you do something great in R, we're okay with it. We can work with it, and we can probably translate it into Python later, or maybe figure out a way to productionize R code. So that would be their take. Although some people, maybe more extreme, and say, hey, we only need people who can do stuff with Python. We cannot manage anyone else. And there may be people who may be more accommodative, but that changes from person to person. If you're looking at people who are more hiring for the sake of data science and more the type A side, then they would not really care. They would not even worry if you use something weird like Julia or Scala. They would be still perfectly fine, even if you don't use even R or Python. They only care about the job getting done and you being able to solve the problem, the business problem, and having scripts that work. As long as it's an open source tool, right? If it's like, say, MATLAB or SAS, then they will be concerned because it's not an open source tool, so they have issues there. Now coming to R, again, a lot of people that are not looking at it just from the lens of a software engineering manager, or like a software lifecycle they don't really care about it. So those are the people who are very happy with people who use R or Python. As long as they do a good job, they're completely happy with them. What is popular? That's a good question, right? From a data analyst perspective or a type A data science perspective, both ways. R is much popular. Python is growing much faster though. R grew initially much faster, but now Python is growing more in terms of numbers. From a type B perspective, Python is very popular. So it depends on the company you're choosing, right? If you choose a pharmaceutical company like Pfizer or I don't know, like Merck or Johnson & Johnson, it would be very much R shoppy there. If you chose, I don't know, let's see. I mean, companies like Google, internet companies like Google, Microsoft, Amazon, Facebook. These days, they're so big that they have a big chunk of people doing both, so they don't care about it much. So you could be R or Python there. But if you're going to a very software-intensive environment, then people would be, and a lot of people do not know about type A data science, right? In that case, they're more inclined towards Python. Now, even in the big internet companies, there might be engineering managers that are solely looking for type B data scientists. In that case, they do care for Python than R, more about Python than R. So that's the perspective. Any other questions on that topic? R versus Python. Do you want to know about pros and cons of R and Python maybe? At least one thing I can mention, Python is more scalable. R is not as scalable. But Python is, so now the pro of R is the open source ecosystem of libraries and packages that R has access to, R packages. They're way more extensive in terms of problem solving and kinds of new models or old models, whatever the modeling aspects of things go. R is has a lot more available than Python. Python is still not bad at all on that front, right? In terms of popular things like deep learning and stuff, Python has a very good access to packages like what is known as TensorFlow and Keras and MXNet. These are popular deep learning frameworks that both R and Python have access to, but Python has access to them as well. So from popular perspective, it doesn't matter. Like the support vector machines and random forest. Python, people use, what is very popular in Python is scikit-learn. That's the library people use for doing machine learning in Python.
Hey Pranit, I have a quick question. Can you speak a little about companies like OpenAI and DeepMind and what they are, these open source libraries that they provide?
So more about the libraries or about what kind of people they're trying to look out for the hire?
It's more kind of the libraries and resources that we can use from them.
Yes. So I've not heard much about OpenAI, but I've definitely heard of DeepMind. So DeepMind is basically this Google's kind of thing, but it's solely inclined towards deep learning, right? So all they care about is more about deep learning at scale, right? So they want to use, what is popular in that aspect is basically MXNet. That's very popular. They would also like to use, or they'll be aware of TensorFlow, which is something that Google came up with, but it's available to R and Python, both R and Python. TensorFlow. These are the scalable aspects of deep learning, because there's a lot of deep learning that would also require architectures like GPUs, so you cannot run it on a CPU anymore, like in your laptop or system. So you need a GPU cluster, which is very costly, but NVIDIA is manufacturing really good GPUs, very solely tailored for deep learning. And a lot of people launch these GPU clusters on a server and then start using that. So these are the ones, these are the kind of things they would be thinking at DeepMind. And then there's Keras, K-E-R-A-S. This is a lot easier to use, but you cannot do something more foundational like you would do in TensorFlow. So the way you can think about it is, it's like a Lego building blocks is what TensorFlow is. You can do a lot of things with TensorFlow. You can build your own deep learning architectures and neural networks. But in Keras, it's easy to use. You don't have to build everything from ground up. So it's very easy to use, but you can only use what they allow for. So they only allow for some architectures that you can easily use with just 2-3 lines of code, or like not more than 5 lines of code. So you're just making a function call basically and does everything for you. That's the Keras kind of thing. But if you're also looking at trying to implement, so companies like H2O and DeepMind, they're also, apart from using these popular packages, they're also trying to implement their own versions of the popular techniques within the neural networks or deep learning community. So they're looking for people who can really understand how the technique works internally. So it's, and also the ones who can literally implement it at a scale. So it's the other end of data analyst, right? Data analyst is someone who's not good at either type A or type B, but is a mix of both. But here we're looking for people who are very good at type A and very good at type B. So these are like very good people on both sides. That would be the ideal persons there. But obviously they would not be able to find everyone of that kind. So I'm sure they would have a mix of hires that are very good at type A or very good at type B. But some people are kind of really good at both to some extent, much higher than what a data analyst is going to do in both on the mix. So there you really want to implement your own stuff. Yeah. Let's see. Any other questions?
Yeah, we are good, Pranit. So
Okay.
I have so when we are having like this interview times and all, I know like companies expect a lot while we get interviewed. Now they want Python and R to be very. So if you are good at like through our assignments and whatever I see data science from the start, I've done everything in R. Like so, like getting to know Python, it's also easy if you know something in R. Are there like these big companies, whatever you say, like people technologies they know? Do we need any other technologies a part of this?
Yeah, something that would be attractive is if you have a few projects in R, a few projects in using the same kind of thing in using scikit-learn in Python, right? It's very simple. Scikit-learn, what you're learning, the same concepts would be applied in there. You, instead of using the SVM function call, you'd be using from R, you'd be using the SVM from Python, right? From scikit-learn. So only the syntactical aspects would change. Neither would make it things more harder or easier in terms of finishing the project. So maybe having some Python projects, right, would also be good along with some R projects for the standard machine learning stuff, for the standard techniques, just something like predicting, the outcome of bank loans, or the kind of projects you're doing, like the Boston housing, these kind of things. Few from R, few from Python.
Yes, and yeah, and whatever the assignments we are doing, we can portray it as a project, right?
Yeah. Yes, you can portray as project. The same thing.
Yeah, like
scikit-learn as well. Exactly. It's just the tool.
Yeah, like when I had the initial talks with Hemant, he told me in turning them into words or some 2 or 3 lines, like how can I I might need your help also in the end, like not now.
Yes, that is part of some of our offerings. We definitely can help brush up your resume and give some ideas to really we put it in the right way. So yeah, I'll be happy to go over your resumes at that point. But in terms of other technologies now, so this is one thing that goes into the resume. From your same question, in terms of other technologies, what is good to have is some data engineering tools, right? These days, things like Spark. You don't have to do Spark by yourself directly from the command line, but maybe through an interface. Spark is this big data handling kind of thing, right? Where you have, it's a scalable architecture, but you have interfaces to Spark from R and from Python. So you can search for RSpark or PySpark. They're very beautiful blog articles or articles that will get you started within this doing just by following what he says on that page. These are very easy things, right? It's not like writing triple for loops or anything like you've been trying for your cross-validation assignment. It's much easier than that. So it's more about getting some knowledge about that architecture and going through those blog articles and exercises. So having something like Spark is very popular these days. From a deep learning perspective, having things, you don't need to have everything. You need to have at least one out of, say, if you had one out of TensorFlow or MXNet or Keras. Keras is a little easier. It would also really outshine your resume. just by the fact that you use that. So in the coming chapters, at some point, we have a neural networks chapter, and in the advanced course, I guess, we have a deep learning chapter. So there we can also do something with one of these technologies through an interface with R. So there is R TensorFlow or Pi TensorFlow. You can use that. And then you can solve the same problem using that part of the code. So you'd be writing R code, but you'd be using some function calls through TensorFlow syntax, basically. But it's worth an exercise. The reason I say this, you would be surprised to know that even in the most sought after companies, like the Googles and Facebooks and Amazons, a lot of people are still trying to catch this deep learning buzz in terms of their resumes or adding these things into their resume. Because the deep learning buzz is moving so fast, and it's sometimes being attributed more credit than it should be in terms of what it can do. But regardless, the perception is everyone is just talking about deep learning, right? It's written everywhere on LinkedIn or wherever you go. The thing is, you can exploit this fact and make sure that you're also not left behind that bus, right? You don't need to be the deep learning expert, but you need to be someone, if you end up being someone who can at least mention some of these technologies in their resume, right, fairly, because they have done some mini project using it, it will take you much ahead in being perceived as a more attractive resume. Because, like I said, even the big companies and most sought after places have really good people doing really good work who are trying to catch the deep learning bus, right? They're very talented. They know a lot of techniques and problem solving, right? But they've not done as much deep learning because it's a more new thing, right? So they're also beginning to use MXNet, beginning to use TensorFlow and these kind of things these days. So these are the ones that will give you a much bigger boost for much lesser work, basically. Because you're not developing thousands of lines of code of how TensorFlow works. You're only using that library within your R or Python ecosystem, so it shouldn't be too hard, as long as you know how the techniques work to some extent topically. So these are the other technologies apart from R and Python. SQL is very important these days if you can query in SQL, right? Maybe if you're able to write some basic queries, like the select statements, and also if you can write, if you can do some joins between tables, like the inner join, left join, right join. If you can write things like aggregate statements like the group bys and then also do things like min, max, average. These kind of minimal stuff that comes in any basic SQL tutorial will be very useful because regardless of all the hype around big data, there's still a lot of people that use SQL, MySQL, or PL, whatever, some variant of SQL. So it's always good to know that you're able to do some data handling yourself, and you always don't have to be relying on another database guy, even if not a data engineering guy, just to get data for you to work on a day-to-day basis. So it's good to have some SQL in your resume as well for other technologies. Any other questions on this general topics? Any in the same question or other questions that are relevant? Okay, so I think we can shift gear now and cover at least a few slides on the next chapter that we had in our syllabus, which was random forest. I really need to put on my computer charger. So that's a quick break I might need to take here for a second or a few seconds. Hold on. Okay, so I'm going to share my screen. Okay, you'll be able to see my screen now. So that's the topic of our presentation, random forest. We're not going to cover everything today because the point of it is not to just walk through like a device or whatever, but be able to understand at least some basics. So random forest is the name of the technique. It falls under family techniques known as decision trees. Or no, it could be used again for classification or regression problems. Okay.
There's also concept of ensembling, which is also something that Random Forest uses as part of its working, apart from the fact that it's a decision tree. Ensemble methods is the idea, are these methods which are the ideas that you're using to combine the predictions of multiple methods. So instead of using one technique, like say SVM or neural networks, you want to use multiple techniques. And so you have these multiple intelligent learners that are giving you their opinion of what the output should be, whether it should be class A or class B, whether the email should be classified as spam or no spam, or whether you have to say fraud has been detected or not detected, whatever your business use case is. But you have multiple intelligent learned algorithms or methods that you're using to get an answer. So everyone will give you multiple answers. So what is the good way to combine the opinion of these multiple expert learners that you've come up with? So that way of using multiple methods and combining their results in some way is known as ensembling. So these are called ensemble methods. One very simple way to ensemble is just by voting, right? You want to see what is the majority vote if you're using 10 techniques, right? Or 9 techniques saying this particular row number 5 should be classified as class A, then maybe that's the majority vote. That's just an example of ensembling the opinion of multiple methods. So that's what we're showing here, but Random Forest also uses this philosophy of ensembling within it, as we go and see more about it in the next slides. So here basically a little more notation I'm showing in a generic way. So if your H was your final learner that is going from your feature set X to your label set Y, which is either -1 or 1 in a 2-class problem. But it could be defined as a sum of, or an average of 2 learners, H1 and H2, which are 2 methods, right? So, and then you can have some linear combination. Maybe you're at like a weighted combination. Maybe you want to give a weight of 5 to this and a weight of 2 to this, right? That weight could be alpha, so it's a linear combination. And then since it's a classification problem, maybe you can put a sign function which will say in the end after you do the linear combination, if the sign is positive, then it's class 1. If it's negative, it's class -1. This is just one instance of what an ensembling could be, just like voting was an instance. This is another instance where some sort of averaging is being done. So on average, maybe you have some individual weak classifiers, but on average, maybe they're doing better than any single classifier, right? Because you're taking more. This is just another simpler example of what ensembling could be. Okay. Now, in terms of ensembling, now apart from averaging and voting, there is a little more refined ways of thinking about it. So there's concepts of bagging, which is a short form for what is known as Bootstrap Aggregation. Bootstrap Aggregation. By the way, Brayman was a professor in statistics from UC Berkeley. He passed away a few years ago. This guy came up with the random forest algorithm himself. So he was the developer of that technique. And he obviously did a lot of other wonderful work in the area as well, apart from just random forest. Okay, so, and then there's other things you want to know about in terms of just the landscape, in terms of the terms. Then we're going to figure out how each of these work individually. Other terms are called boosting, but that's not something we discuss in our slide. Why? Because bagging is one kind of an ensembling approach that Random Forest uses as part of it. And since we're discussing Random Forest, I want to use this opportunity to only discuss bagging and not other kinds of ensemblings, which we will do separately. Okay, now, in terms of bagging, we want to know what bagging is, right? So it says Bootstrap Aggregation. So you want to know what Bootstrap is. So basically, bootstrapping is nothing but averaging your results. If you have individual learners saying individual things, or if you're estimating something using individual experts or individual functions, you want to average them. But one thing you want to make sure is you want to compute this function on the X, the individual functions that you're averaging. So if you had B functions that you're averaging to get the final estimate of your result. So you're summing up and averaging, right? Sum and divide is what average is. But what changes is the way you generate your X that you feed into these individual functions. So when you generate your X, there's 2 ways you can generate it. One is you can sample your X from your data set with replacement or without replacement. Now, what is this with and without? So if I put some 2 colored balls in a bucket and give you, and if I tell you to take 10 balls out, you take one at a time, you put it outside the bucket, you take the second ball, you put it outside the bucket, you take third ball. That is sample without replacement. You take one ball, note its color, you put it back. You take another ball, again you note its properties, right? And then you put it back into the bucket. So there you're replacing before you take the next sample. That's called sample with replacement. The beauty is if you sample your data set, so if you have a data set of 1,000 rows, and your 1,000 rows are not exactly the same. That's the reason it's a data set. If it's exactly the same, it's a very naive data set, right? If I take one sample, one row, I would know everything about it, the rest of the rows. But the reason that it's a data set means each row is having its own different properties that it's describing through the columns or variables, right, through its features. And obviously, some properties and feature variables or some columns in your data set are more often occurring and more prominent, right? So if you're describing, as an example, if you're describing 1,000 students and the heights of students, what you would see among your rows, if you keep sampling, you would see that maybe between 4 feet and 5'5", you would have 5'7", you would have most of the students. And so those are that's the property of the height, right? That is more described by the majority of your data set. And students in high school that are over 5'7" and about, like about 6 feet or whatever it is, or like below 4 feet is the minority, right? There's some reason you don't see those people very often. So there's a property that you're looking at. So the good thing is this property is kind of a generic term I'm using, but basically there's a distribution in your data set. Some things are more prominent and you would see them more on average. Some things are more outliers, right? Some kind of properties in your variable. So if you sample with replacement, so if you take one value, put it back into the distribution, take again another value, put it back into the distribution. And what's going to happen is the shape of your distribution or the generic behavior in your data set would also show up in your smaller sample. That's known as the Bootstrap sample, which is nothing but sample with replacement. Is taking into consideration that when you put it back, if you do that so if you had a data set of 1,000 and if you do a sample with replacement and you pick up 100 items from your data set, but every time you're putting the thing back and taking the second one, you put it back and take the third sample to do that. And then if you plot the histogram of your original data set and if you plot the histogram of your 100 samples that you picked with replacement, the shapes will be very similar. So sample with replacement is a good way to respect the fact that the distribution has these properties, your data has a distribution, and then you also want your sample to show that distribution in some form as an approximation. So when you do bootstrap bagging with replacement, and then you get these x's differently every time, and each time you compute your function because you have multiple learners that you want to combine because this is an ensembling we're talking. So the multiple learners are the f subscript b. You have capital B of those learners. You average the performance of these FBs on a data set that has been obtained with replacement, sample with replacement, is basically called Bootstrap Aggregation. So this is another way, because we were talking about how do you combine methods. So we thought voting was one way, some sort of averaging was another way. Now a more refined way is bagging, which is an average of your estimate of your functions computed on a data set which has been sampled with replacement. Okay, so that's what it is. So basically, in random forests, so FB could have been a neural network or SVM applied on a resampled data set, but in random forests, you're literally resampling your data set and then you're generating a tree. We've not discussed how the tree is generated. So each FB could be a random forest itself and you're averaging the random forest, right? So each time you fit a decision tree, as we see in the following slides, and then you're combining the results of your multiple trees. And that's why they call it a forest. So each time 100 trees is a forest, right? It's a crude language, but we're trying to generate B number of trees individually in a resample data set. Each tree will give its decision, and then you want to respect all the decisions and come up with an ensemble or like a combined decision, which is an average of the decisions. Right? So this is called bootstrapping applied to random forest. That is what random forest is. So this is a very zoomed up, like a high level description of the random forest algorithm. Obviously, each individual step of it has a lot more finer details to it, but it's good to look at the bigger block diagram of the approach here first. Okay, so basically, this is the approach. If you're planning to generate B trees, capital B, so for each time you do a bootstrap data set. So from your original data set, you're taking a sample of a smaller sample of other data set. So each of these data sets goes and develops one particular tree. So you do that B times, you're generating B resample data sets and you're getting B results. What is your thing you're doing on each individual data set? You're building a tree. How are we building it? We would see in future slides, but assume we would be able to go over it. So say assume we already knew how to do that. So we would build a tree, let's call it FB, on that resample data set. And in particular, what you're doing is if you had a data set of 1,000 rows and 500 variables, you're not using all the variables, all your features on each tree. For each tree, you're only using a subset of variables. So this is another way of averaging. So you're trying to build a weak learner, but multiple weak learners you're combining to get a much stronger learner, which does better than any individual learner. So each time you are generating a bootstrap data set, and then in particular, you're selecting only a subset of your features as well, not just the rows. And then on those smaller subset of data set that you have, smaller rows and smaller columns, you're building a tree. You do that B times, so you have B trees. And then the output for regression is just the average of your B trees that you built through the bootstrapped process. And for classification, you're doing the majority work, right? Which tree believes this any given row should be classified as whatever class as a majority, right? As a majority of all the trees, which tree would contribute to the majority is what you would consider, right? So if you have 1,000 trees, if your B is 1,000, you build 1,000 trees, and if 990 trees say any particular row has to be class 7, it would be class 7, or class 2, class 2. Okay, this is something that you don't have to worry about at this point, then less than repeat. Now the question is, how do you build this individual trees? Now you know the zoomed up algorithm, you want to know how you build the individual trees. Any questions at this point? I know this is a very detailed technique that we're going into the workings of, but do you have any other questions at this point? Okay, so moving along. Now we want to look at how we build a decision tree and what a tree is that you're building in your data set, because you're building a lot of trees and averaging the result, or taking a majority vote for classification regression. So this is a tree that we're talking about, and basically this is a tree structure, right? This is known as the root. This is known as the head, and these are the leaf nodes. So what happens is, let me give you a very generic example. So if my problem is to classify emails as spam or no spam, and build a machine learning learner to do that automatically, what I would do is at any given node of this tree, these are known as nodes, at any given node, what I would do is I would choose one particular variable out of your features, right? You have maybe a data set of 1,000 variables and 500 features. I want to choose one particular feature out of the 500 and make some decision based on just that feature. So maybe I chose a feature called how many spam-related words are in my email is maybe a feature. Maybe you had a feature that has a count of how many spam-related words. Now, what's a spam-related word? It could be, something that is very much marketing intensive, right? It could be maybe you're selling some drug, or you're selling something very irrelevant to the usual data set that you deal with your emails. So you want to count how many of such words are coming up. That could be a feature. So maybe if I want to take a decision only based on that one variable, that's what I would do at any given node. I'm only making a decision based on one particular variable. So here I choose one variable that I consider is the most important to classify your data set to start with, if I were to only choose one. Maybe it could be the number of words that are spammy in any given email. So then the rule would be, if there are more than 7 words that are very spammy in any given email, then it should definitely be considered as spam. So that would be my rule based on one variable. Now, what happens is you reduce your data set to only those rows that satisfy this particular condition in one particular column. Now, within that subset, now you want to come up with some other rules. You want to say, hey, which other variable, given this condition is satisfied, what is some other variable that I can choose? And then I can put some rule on that variable, some threshold, right? Greater than, less than, or equal to threshold. Then I might say, hey, emails coming to this person from a location that he never gets emails from. So say I never get emails from one particular country in some particular continent, but I usually get emails from a lot of other countries. So then maybe this could be something spammy, like why is someone contacting him from somewhere that he has no connections with, right, on a day-to-day basis. So maybe that may be my second variable. Now maybe I need a threshold on that variable. Maybe that's the variable I want to use here, but I want to know what the threshold is. Is it supposed to be just one email coming from there with just 5 lines, or if it is an email coming with 2 lines, or is it an email coming with images? Is it an email coming with a lot of other details? Is what the finer details are here. So here I figure out something about the second variable that I choose to make a threshold. And then within a smaller subset that satisfies this condition in one variable and this condition in another variable, specific condition in this variable is what I'm coming to when I come to this level of the tree. As I keep going lower, I'm making more and more decisions. So my rule gets bigger and bigger. So once I come to the very end, I would have consumed all the variables by now. So because I'm making one decision per variable. Or I could do something complicated where I make a decision based on 2 variables here, and a decision based on 3 variables, a decision based on 4 variables. But in the end, I'm coming to a state where I've used all my variables to come up with a very long rule. So in the end, all I have is, if all of these rules are satisfied to come to this particular node, then I would say this is a spam email. But if all the conditions are satisfied to come to this node, then I would say it's a no spam email. It's a good email. So basically the leaf of your tree, by the time you come there, you traverse there, you have a final label. So the leaves are basically labels. But if you want to label some row as spam or no spam, you need to traverse through all the particular conditions and see which conditions your particular row satisfies, and wherever you end up. And once you end up, you would see, oh, this is a spam label or this is a no spam label. That's how you classify your data set. So the point is, the terminology is, how do you split your data set, right? Which variable do you use, and at what threshold do you split your rows, your columns, is what the next question that one needs to answer. So let's see where we are on time. Yep, so we just hit the mark as well. So you got some idea about what kind of a family of techniques random forest is, and what are some philosophies and ideologies that are used in it. We would get into more deeper details of developing a random forest tree on any given data set further as we go through all these in our coming lecture and next week. So I got some assignments back from some of you, and some of you are still working on your improved version of the support vector machine. Especially the important part is not about support vector machine, but about implementing your own class validation, so you get a better understanding of it. So this is a very important concept. So you can maybe kind of conclude on that, the rest of you as well, and try to get a reasonable job done and have it sent to me in the next coming day or two, I guess, so that we can move on to the next assignment after that. And it would be something to do with cross-validation as well, but we'd be doing some more refinements of what you would have done by the time you have submitted the assignment. We would do some of the next logical steps that follow after that. Any other questions for now?
Hey, Pranit, I have a small question.
Yeah, go ahead. I think there were 2 questions. So yeah, let's start with Mani, then go to Krishna.
Well, the thing is, like, when I'm sampling this, right, in the K4 class validation, let's say, when I'm taking a sample, of me, so the thing is, like, when I have 20 different parameters that I'm using, and once I use a specific data set of n values for those 20 parameters by using the sampling technique, and the second time I repeat the same thing with a different data set, does it matter to compare those, or do I need to pick up the same data set for the second time when I'm comparing things?
Okay, so just to confirm, the 20 parameters, you mean the 20 parameter combinations, right?
Yeah.
20 of those, yeah. Well, good question. You only shuffle once in the beginning of your data set. Then your folds are decided, right? Which is first fold, second fold, third fold, fourth fold, fifth fold, right?
Yeah.
And that's the only time you sample. You don't resample again and again. That's only once you do the shuffling, because you made a valid question, right? Because if I keep resampling again, what's going to happen is the data set I'm testing for checking the first parameter combination is going to be a bit different, or maybe a lot different from the data set I'm checking for the third parameter combination, because things are getting sampled every time. So things, you're not comparing the performance of this technique across different parameters on the same data set. You're comparing on different data sets, right? Because it's different shuffled version.
But mathematically it's not true, but statistically, can we, like it's the same data though, but yeah.
No, it's ideal that you keep, when you're comparing two, doing some experiments to compare some different properties, in your case, the parameters, you want to make sure everything else is constant, right? You don't want to, otherwise it's going to add more noise into your list.
Yeah, sure.
So ideally, once.
Yeah.
Cool.
Thank you, Pranit.
Yeah, so I saw Krishna Kamal had some questions or comments as well.
Yeah, Pranit. Like I asked in my email.
Go ahead.
So when I'm doing it through Tune, I got a cost value, but if I like I of 100, am I or something somewhere? Will there be different with the Tune when we use the Tune command or when we do it manually?
Oh yeah, I saw that in the assignment. So you're saying you had, I saw that email came in today or yesterday. Let me open it again. So I saw the numbers you mentioned there. Yeah, I got it yesterday night, afternoon. So yes, so this was the question, right? When we did Tune for the same data set last week, okay, yeah, we got the cost as 10 and we are getting cost 100 now, right? Okay, so here I have a couple more questions before I confirm that I'm answering you for the right question and not something else. So when you said when you get the cost as 10 or get the cost as 100, what are you trying to point to? By getting
when
the best cost that gave you the least error or something else?
Yeah, the best cost that gave me the least error.
Well, ideally, if your data set didn't change and you're not resampling and shuffling it again, even if you resample it, it shouldn't change that much. So if you use the same function on the same data set, right, you should be getting a same or a very similar. So this should not be happening.
Okay.
Now, so it could be very well true that your most recent submission is the correct way of doing it. So maybe that is the correct, or maybe the correct one was done there, or there's something in the middle that is correct. I mean, both are kind of a little off from the right answer. Ideally, we do it to get you to this one particular cost in gamma. By the way, also looked at the cost and gamma combinations and choosing which cost gamma gave you the best result, or have you looked at cost first and then gamma after that?
Same in both the cases. Point. I got 101 for one of the combinations last week as well, but 10 was more
yeah,
in all the
yeah, I didn't change much. So you're talking of, here you have 10 power minus 1 to 10 power 3. So here you have 3 values, right? So,
5 values.
Within cost, you only have 3 values. Because minus 1 to 3. So minus
0, 1, 2, 3.
0 is also going in. Okay, yeah, you have 5 values. Okay. You have 2 small values, then 10 power 0 is 1, then you have some bigger values. Okay. And you are using gamma, this is correct. Yeah, I'm making sure that at least this, because this is the most recent one, hopefully this is in the right direction, then it should not change. Let's see, here you're going through the parameter combinations every time you're training it. Now, is there another for loop here, or at what point are you doing the 5-fold thing? So this is
yeah.
Okay, let's start from here. So this is your, okay, this is an SCM model. This is good. This can do any train predict based on what you pass, right? Now you can pass in the required folds in here the way you want.
Yeah.
Okay, then you have data sets function, home data. What is home data referring to? Like, how should you divide the data?
The home data is the data that we are taking.
Right, okay, the iterations now. The iterations is
Are
referring
the number of folds.
something else. Sorry?
Pricing. The number of folds that we are.
Okay, very good. All right, and then
Yeah.
now you're going through that. Want to do is to do the shuffling outside. So this is this is one thing. So that's maybe one more reason for
Okay.
this changing in your results, right? Because yeah, so this thing, what you want to do is you want to shuffle your data set once. So you only, if you have 1,000 row data set, you pick all the 1,000 rows, but they're going to be shuffled up, right? So the rows should be shuffled up. You do that at the very much beginning. And then you would divide those shuffled rows into 5 pieces, right? 5 subsets of 5 folds.
Okay.
Which is the same as saying you're randomly choosing which row falls in which fold out of these 5, right? You shuffle it and then split it into 5 events. And then you go through this process of each time you drop one fold and you use it as test and you use the rest as train, right? That's what you do. And then you do all of that for every single parameter combination. Like we did. Then things are not changing across parameter combination. Okay. Yeah. All right, but the structure of your code looks so much better. It looks very professional now. I'm not saying it's already 100% correct, because there's the sampling thing we will change, refine a little more, but that's the process of this, the process of the game. The game is that, right? You keep refining your code, the point of coding anyway. And I've not checked everything else, but I will check the rest of it when I do the evaluation of this. Cool. Yeah. Any other questions?
The other request I had was like if we can use, I mean, many plots or anything like in like.
Yes, that will be your
day-to-day life.
That will be your next assignment. Not just the day-to-day life. There is some plotting that you need to do even for your cross-validation project that you're doing right now. That will be your next assignment. There will be some plotting and stuff you will be doing, more refinement. But we want to have this current thing working perfectly, which we are working towards, the refinement. Then we will get to that.
Okay. Yeah, thanks.
It will come up in some future lesson as well. Yeah. Okay, so very good. So yeah, any other questions? Anyone? Okay, very good. So all right, so everyone have a good rest of your weekend, and let's keep this going on. I'll see you again next week.
Thanks, Pranit.
Oh, okay, I thought you were asking a question.
No, I just said thanks.
Okay, yeah, welcome. Yeah, good. So have a good one. All right, I'm calling it a day. I guess the recording can stop at this point. Okay, I'm calling it a day. Have a good